And here we see that the predicate is a dependent type, which is unlike what other impredicative encodings can do. And this works because SPROP is the types in SPROP are proof irrelevant. So our hypothesis here of type 4x pi squash also has type A arrow px, because this A is SPROP, so this x is the same as I squash. So then, suppose we try to put this inductive type in SPROP. Having two constructors in a type in SPROP means something. Means we have to restrict elimination, otherwise we have a problem. So this is the same thing as doing the squash of booleans. And so doing the squash basically means we can only eliminate two SPROP predicates. So this is sort of like what happens with types in prop which don't have singleton elimination. There is also a restriction on fixed points, which is less about consistency and more about keeping the type theory decidable. We will see more later. So until now, we still can't get out of SPROP once we are in. So we need a way to get out, and that way is the empty type. So if we define it with the impredicative encoding, we still can't get out of SPROP. And that means we need to allow the empty type as an inductive type with unrestricted eliminations. So if we don't have that, we could say SPROP, it's not the type of irrelevant types, it's the type of unit types, which is pretty useless. So we must have at least the empty type, and that's already pretty useful. So for instance, this inductive type is the same as this fixed point of inequality on natural numbers. So basically we decide it, and we have leaves of either a unit, which we can do with impredicativity, and empty, which we said we can. So for convenience, we can try to detect when we can do such encodings and allow eliminations for such types. So inequality is maybe a bit too complicated for that to work, but some stuff will work. There is one that probably won't work because it's way too complicated. It needs unification a la Agda. So we define when an element of a type is in the image of some function, and then we say that if we have an inhabitant of that type, then it is always equal to the constructor. And this is the same as this definition by equations, which just works in SPROP, but it's complicated to figure out that this fx can be ignored. So we also have a question of can we allow identity types in SPROP? So for instance, the identity on booleans. So this can't be encoded because there is an issue with defining elimination with the proper reduction rule or the proper conversion rule, if you prefer. So basically, if we eliminate an identity, and that identity has the same type as ref, and it's converted. If we encode identity by deciding it, then it won't reduce when the booleans are not true or false. So we can allow it when we have A is strict set. Coq calls that bishop set, B set. So maybe I should rename the concept. So the point is we can allow it for some types, but not all of them. It's tricky to figure out which types, and that hasn't been done yet. So suppose we allow any inductives to have unrestricted elimination, which have some constructors. We need to do this reduction, and it is guided by the type. So we call this case inversion, and we will need to be careful to keep it implemented, possible to implement. So the semantic criterion for putting an inductive type in SPROP, or generally saying it is strictly irrelevant. So we can present any inductive type as something looking like this. So there is a type of indices, there is a type of non-recursive arguments. Then we do some stuff with recursive arguments, and we land in the inductive type at some indices depending on the non-recursive arguments. So basically, the recursive arguments cannot hurt us. And if we can linearize this by introducing a variable, so we say for all y equals iota x in t y, and then this makes the fibers of iota appear in our constructors, and then we can prove that if these fibers are irrelevant, then the inductive type is irrelevant itself. So this is, in other words, when iota is an embedding, and then we want strict irrelevance, not just propositional irrelevance. So it's some sort of strict embedding concept, which can only be expressed when we can talk about strict equality, so in HTS or extensional type theory. So how do we detect it syntactically? So for instance, constructors in a simple data type are embeddings. So for instance, the constructors of natural numbers. And we want something a bit stronger to be able to deal with dependent types like dependent pairs or stuff like that. So we call this concept invertibility of a constructor. And a constructor which is invertible has some arguments which we call forced and some which we call real arguments. And they verify the following properties. So first, the inductive type must not be squashed. So if it's in prop, it must have singleton elimination. If it's in S-prop, it must be naturally S-prop, etc. And for other inductive types, they are never squashed, basically. And then the output type, so the iota here, looks like a tree of constructors, linearly appearing variables, and some extra stuffs if we allow some identities. So, for instance, here, this first b is a parameter, so we ignore it, and this second b is the extra stuff, which must be in a strict set type. So we ignore the first arguments of the constructors in the tree, and every variable which appears is a first argument of our new constructor. So being a first argument means if we know that a value in a certain type is of a certain constructor, then we can recover the first arguments from the type. And non-first arguments cannot appear in the output type. So that can only happen for the extra values, of course. So if we have such an invertible constructor, we can prove that the iota is an embedding. So in that proof, we have a recursive hypothesis on the previous that the invertible constructors apply to only the first arguments provide are embeddings, and then embeddings compose nicely. And we could mess with universes a bit by ignoring first arguments. So let's ignore that. So the full criterion that I've implemented is that the type is allowed in SPROP with full eliminations if it's the empty type, or if there is a single constructor with only first arguments. So this does not allow the product type, so A cross B, even if A and B are SPROP types. So we also allow real arguments if they are in SPROP and we are defining a record with eta. So otherwise, we have problems with case inversion. So case inversion, we have match X with some stuff. And instead of looking at X, reducing it to get a constructor, we look at the indices. And if we can unify with the type of the constructor, then we get values for the first arguments and some proof that applying the constructor to those arguments gives the right type. So to get this, we must annotate such matches with the indices so that we don't have to retype when reducing. And if we have the extra value stuff, then we must also do conversion during reduction. But this should be okay because we only have to do it when someone actually wants to use it. If you don't put any identity types in SPROC, it never comes up. So why do we allow non-forced arguments only for records? Because otherwise, when we do case inversion, we would have to define the projections to get the real arguments to the constructor, and this is both hard and it will produce ugly raw matches. So we just don't do it and use records with primitive projections instead. And then there is an additional restriction on fixed points, possibly because the core foundation of Coq is too smart. But so let's define the empty type, but with one constructor from empty to empty. And then if we define this, we can match it out and get another empty. And this inf function produces a value which is smaller than its input, so we can do a fixed point on it. And then if we have that fixed point, it's the same by proof irrelevance. It's the same as the fixed point applied to a constructor, so we can reduce, and this has an inv, and then we can reduce this invrec into just the input, so we get finv, and then we can just keep going forever, and there is no way to stop, so we are broken. So we just forbid such fixed ones unless the output is in SPROC, and if it's in SPROC, then we don't have to do any unfolding because everything is equal. So we should. Oops. So we also have a problem with cumulativity because we can do strange tricks with types to make it hard to figure out that something is in an irrelevant type. So for instance, this one, we say if true, then unit, else not. So this is just unit, but we have to do reduction to figure it out. So and then that means we could generalize true, and then we have to do substitutions and stuff, and it's just not really feasible. And we can also do stuff with primitive records and eta. So this means, so here we stick unit in a box, and we can open the box because we have eta for the box. And once the box is open, we can use proof irrelevance, and so every element of the box are equal. So this is also not really possible. Okay.
What would you do if true was an abstract Boolean, a parameter?
So if true was an abstract Boolean, then we would not be in a SPROC type, so they would not be convertible. But later we could substitute the parameter with true, so something turning into an irrelevant type can happen at any time, basically, at any reduction step, stuff like that.
So what you're saying is that currently you don't have cumulativity of SPROC.
Yes, it is forbidden. I have an option to allow it at the cost of completeness of the system, but it doesn't work very well. So let's ban cumulativity, and let's ban putting SPROC things in primitive records if they land outside of SPROC. So if we have this, then we have an assurance that every irrelevant type is in S-prop and every S-prop is in type. So to be able to talk about irrelevant types in a relevant context, so basically we want to lift them, and we do this through inductive types which break the irrelevance property. So for instance, this box, not as a primitive record, but as a regular inductive type is allowed. Even so, S-prop is not less than prop. It sort of is as far as inductive types go. And for ours, this is the same principle. We have the max, which just works pretty much. So how fast is this? So to check that something is relevant, we need to do that at every conversion step. So to do that reasonably fast way, we need to mark every binder with whether its type is in S-prop or not. We also mark so fixed points count as binders, for instance, and we also mark matches with the relevance of the output type, because otherwise on the empty case we have no information. We have to retype stuff. So this is enough annotation that when we have a term, we can just dive down right to the head and figure out if it's relevant by looking at the marker. So performance, we do have some cost. So most developments are around +5 to +10%, and Bascomp has an even example where it goes to +22%. So hopefully this can be reduced. We will see.
So what plans do you have to make them acceptable?
It's not planned yet.
I'm willing to help.
Pierre, don't apply your usual technique of doing some unrelated optimization.
That was the plan.
Won't work.
But that 22 is surprising.
Yeah.
Well,
But even 5 is bad. Even the best is bad.
Yes,
5%.
Yeah. So that's surprising twice.
Well,
and
at some point we have to do some more.
It's not very surprising.
Yes.
It's not. I find. I mean, compared to what you have to do,
yes,
it doesn't seem so bad. So, I mean, that's why I was asking about the ideas. This fast.
I don't know. Marking should. I mean, I would understand that marking takes memory.
Yep.
But time, I'm really surprised.
Well, more pressure on the DC means more time.
What about the retyping comment you had? When do you retype? Only in the pretyper or also in the kernel? Because it's not clear.
Only in the pretyper. Retyping is only in the pretyper.
But yeah, without marks, we will need retyping in the kernel.
Yeah.
During unification? I mean, what do you mean exactly?
Basically, there are a few places where we construct a binder and we don't have the information about the relevance of its type locally, so we have to reconstruct it. So
but does the kernel trust the mark? Or
no, the kernel checks the mark.
Maybe that.
So it needs to compute in type, right? No?
Well, it's when you type things, so.
But that's already there when you check.
So for instance, when you check a lambda, you have to check the type that the annotation is a type, and this means it has a sort, so you can just keep the sort and look at it. So
yeah, but you may need to reduce more there potentially, no? Maybe not.
no, I don't think so.
No, we already do it.
Let me look if I did anything.
But then, I mean, this comment does also apply to the pretyper. I mean, even without your code, the lambda would have a type. If you have to synthesize a lambda, you have to put a type there. So why you need to type more?
It's not for lambdas, it's a few random places like.
Okay, you can just say go to the code and read it. Okay.
Yeah, like generalize, it gets the type, but it's just as a random construct, so we don't have the typing information. It's really random places where maybe it's possible to keep the information somehow, but
yeah. So actually, I did the first experiment on the that a few years back on adding these marks, and most of the tactics and the API take consters, but in many cases, the first thing you do is retake the type of that conster in the API of cat tactics and everything. So if we were passing judgments, or at least just a terminal type, in many cases, then we would not need to recompute outside the kernel at least. So it's maybe also an API issue that could solve this by not rechecking and reproducing the same values all the time.
Are you saying that we are doing stupid things today, or that, I mean, or not?
I think we are doing wasteful things today, but retyping is pretty cheap in general.
I mean, we already have retyping in some places in the kernel.
Yeah,
retyping is not that cheap for one reason, because it actually computes the names of that. There's a dedicated algorithm for printing that is completely nonsense. And that takes time for nothing.
Anyways, before worrying about retyping, let's try to graph this stuff first.
Yeah.
Yes, it's something definitely to do.
Anyway,
Asia is asking question there.
Asia?
Oh yeah.
Yeah.
What is it?
So if what you described was Coq, I guess we wouldn't have written matcom this way. So one of the things you propose is to ease the definition of proof irrelevant sigma types.
Yeah.
There's a lot of effort in matcom for the case when today it's proof irrelevant because of Boolean predicate specification. Do you think rewriting matcom in this spirit would have error or not?
Oh, I have no idea.
Because for me, I mean, it's good to benchmark and to understand the extra cost today, but it seems that it's a code that would be written differently if this becomes master.
Yeah.
I mean, is this one of the motivations to have to ease this kind of development?
Yeah, that.
Or am I wrong?
Also, to make developments where you have problems with stuff that you want irrelevant. So, yeah, just making it possible to use irrelevance.
Yeah, because in matcom there's a lot of arguments about injectivity of projections of this sigma type because the second component, blah, blah. I guess all of this would disappear because things are in as brought now.
Yeah, in conversion with this, you probably gain a lot by not checking things, right? If you know that two things are living in an irrelevant thing, then
yeah.
Yeah, but right now nothing benefits from it in the benchmark we have.
Oh yeah, but maybe, but it would be interesting to understand if we gain something by implementing the math in there in the style which is made possible by this improvement. Otherwise, it's a bit unfair to compare.
It's a good point.
But it's a lot of work, I think.
Is there any experience on porting part of something like matcom, another library, to see not just the penalty, but also the benefits in practice?
How about we get back to this in a bit? I have like 2 slides to before finishing.
Okay. That's good.
So we don't have cumulativity, and this does lead to a few problems. So for instance, we have to duplicate definitions, like sigma types. We have a version with relevant things, a version with only S-prop things, and even a version where the second component is a proposition. So this is annoying and not sure how much it scales. I guess we could also box things. And we also have issues with pre-typing. So let's look at this definition, which is saying that any two elements of an S-prop type are Leibniz equal. So we don't annotate anything in the body. So what happens is A gets a type EVA, and so at this point the system thinks it's relevant. So we get to X, we say it, and we say, well, it has some type which is an EVA, and we think it's relevant. So we put a marker like it's relevant. And then when we get to the end, we will unify the type with S-prop and either fail because we don't have cumulativity, or if we could also allow cumulativity in elaboration, but then the relevance marks are broken and the kernel will complain.
So you have the same issue with prop. Okay.
To some extent, but this is worse.
Yeah, it's a bit worse because you even have a mark that you cannot change.
And, I mean, originally I made the option to allow cumulativity in the pre-typer because I couldn't figure out how to get the match to be elaborated properly. So, yeah, there are various issues which come up, which make it harder to use.
So isn't it a bit similar to a lack of bidirectional typing? Because here the user has written S-prop in the binder type.
Yeah.
Bidirectional typing would help, but there would still be issues, I think.
Yeah, when you really don't know, when you have a binder for a type and you don't know if it's going to fall in prop, S-prop, or type.
Yeah.
Currently, the default is type. And I think that's fine. I mean, we can live with that.
Not quite. We already have the problem prop that things are equally unified with type, and then you get the horrible error. Like when you pattern matching returning type and you actually wanted a prop or a set, like, this thing has type set.
Not knowing what to do when there are notations seems less of a problem than here. Here the user has explicitly written something and doesn't guide the system, if I understood correctly.
That's true.
Or too late.
But you're saying for match? So what's the problem for match?
For match, I think, I'm not sure what exactly the problem was, but even with a fully annotated match, it kept complaining about something about cumulativity breaking it. I think it makes an EVA at some point that doesn't act as it expects.
Oh, so maybe the cases elaboration that's too general or doesn't.
It's a bit too smart.
Yeah, it's trying to be too smart. Yeah.
Okay. So there is a bit of use in the wild. So Simon Boulier defined some proved the Fanex in it, and Nicolas Tabarot did some stuff with cubical types that I don't understand, and which is not fully ported to the current version of S-prop. It's an old version when S-prop was just prop. So this is the end.
So I have a question. Okay, sorry.
So we can come back to this, or where's my mouse?
Do we still need prop?
Yes. For instance, well, at least for extraction stuff, because why?
Yeah, what about extraction?
So if we look at so fixed points. So this also works for accessibility. So that means we can't put accessibility in S-prop and use it. We have so if we want to eliminate it at extraction time, we have to put it in prop. We can't make accessibility be strictly relevant.
Yeah, I think they had the same problem in Lean at some point.
Yeah.
I don't know what they did in the end.
I should be closer into Lean, but
it was a bit worse because I think they had only the only accessibility predicate they had was in the irrelevant sort. So you couldn't really avoid this problem.
But I mean, you could always just not do the unfolding and have a conversion which is not transitive or doesn't preserve.
Yeah, that's what they had.
Yeah. But for extraction, otherwise you just extract it like prop. You remove everything.
Yes, it's even stricter than prop. So.
I mean, you can do functions from prop into the same type in SProp, so you have to erase them, otherwise you have to figure out how to correct this stuff. So I can demonstrate a bit, maybe.
We are slightly late, so yeah, just a quick thing.
So this is broken. So let's look at this predicate, which says that a natural number, some natural number is not zero. So we can use it to define the predecessor function without case for zero. And here we just take this first argument out. And we can define some, and we can find some identities. So here we use proof irrelevance to convert some arbitrary hypothesis into an application of the constructor. Here we have the constructor, we apply it to the constructor, so we reduce. And by transitivity, we have the stuff that case inversion must be able to do. And then we check that it works by proving that identity with refer. So here, this is a test file, so there is stuff that used to be broken and it's not interesting. So what is this? This is boring. So we have the unit record in SProp, and it's primitive, I think. So it's not primitive, but it still has eta because it's in SProp. And it's not squashed. So the product using the primitive record, and we use scheme to check that it's not squashed. If we define the same, then scheme will fail because we have to squash some primitive things. Some stuff, yeah. Yeah, that's it.
So can we start the next presentation?
It's going to plug this in and maybe it's. Why is Enrico half hidden? I don't know.
Yeah, can you move
a bit?
The cam?
Yeah.
No, it's the other way. Yes, and then up to
Or the receive as well. You don't even know Steve is watching.
Eve is moving the cam, right?
Yeah.
Well, it's kind of unfortunate.
Does anyone know?
Back adapter.
Guys,
We've gotten that.
does anyone know if Emilio does anyone know if Emilio is going to join? Because he was scheduled.
I don't know.
Okay.
Emilio. Here, I think.
Can you send the slides?
Ah. Send the slides down.
Or better, put it on the wiki.
Matthew probably has got an adapter, but where has Matthew gone? That's the
Probably to smoke.
Oh shit.
Or maybe it's related to. Well,
I don't know.
Is there a problem?
So,
Oh, you have an adapter.
What's the problem?
Or this is a Mac. We need an adapter to the VGA.
Yeah.
so the problem is that there was no adapter, but Matthew has come back.
Right. But there isn't a problem. Not anymore, at least.
well, anyway.
Maybe we're here.
It's
like it should be.
Would you mind sending the slides on Coq then?
There is no slides.
There are no slides? Oh, okay. And I will move.
Well,
Nina, is it like something happened? Like a flicker. Oh.
Can you just unplug and plug again? The classic.
That works fine.
The classic move.
There we go.
Oh.
Has been checked. Yes. No, yes.
Oh,
here we go.
Yes.
Perfect.
So, right. So I'm just
Bigger.
You should probably present yourself.
So yes.
Okay.
My name is Josh. I'm at MPI SWS, and Kara has been helping me, guide me through re-implementing Coq Checker in Rust, since the current one is not terribly independent of the kernel, which is kind of sad, and it also gives the opportunity for giving a sort of independent analysis of the code, potentially make some stuff faster, investigate and write lots of comments, and maybe fix some bugs. So I'm just going to focus on the stuff that I think is interesting, because I assume most people here are already pretty familiar with the checker, so mostly just the places that I deviated. So the first thing to notice is that the file lengths are all much longer. Part of that is Rust verbosity. It could be fixed with macros to some extent, but so part of it is that we use reference counting in many places, not everywhere. And in Rust, when you want to pattern match, you cannot use the interior of a reference counting pointer directly. So you have to write some boilerplate to extract it, and probably except with a macro. And there's just a few more things like that. Obviously, you have to write type annotations everywhere, lifetimes and contexts and stuff. So it's unlikely, I think, unless I really use macros very heavily, that this would become as small as the OCaml. However, another large reason for the file's length is that I believe that the current kernel is woefully undercommented. It's just there's a lot of very subtle stuff going on in arithmetic, and it's never documented. So if it took me a while, after a while, I just ended up documenting basically every place that correctness seems to rely on indexing. So for example, what's a good example? In I think actually ntypes has a lot of good examples. Right, type check already has some really subtle conditions that it requires, which are implicitly relied on in various places in the kernel. And I've actually found a couple of bugs while I was doing this. So I think it would probably be valuable to backport these to the OCaml as well when this is done. So yeah, that's just sort of some overall notes. Some, let's see, specifics. So one thing that is nice about Rust is that it gives you a fairly precise understanding of which resources are actually shared. I mean, so normally that doesn't matter much because Coq is mostly functional, but during we have sharing, this horrible thing that I'm sure you're all familiar with involving the red states and the Z updates. So there's currently a loop in the OCaml implementation. Sorry?
Sorry, can you, I can't read the code if you move it, so
yeah, that's great.
Maybe put an interesting piece of code.
Yeah, that's what I'm trying to put, actually. Hold on.
I heard you said you found bugs, but I didn't hear if the bugs were in the checker or the kernel.
In the checker. Although, some of them might apply to the kernel, but I think the biggest one here I looked and we couldn't figure out because the kernel is completely different. It could still exist there or it could not.
So is there a place where we can see what we found?
I should really write that up. I can summarize it. Essentially, there is a place where we are running reduction without type checking first during checking inductive types, so we get total garbage there. It so happens that we later check the condition that would have been required to make sure it was well typed. Actually, we check something stricter. So specifically, the thing that's not being checked currently is in the inductive type definitions, the parameter types are basically we just check that the number of parameters is the same, and then we don't actually check that the types match before we start reducing in the. Let me find the exact function. Yeah, here we go. Yeah. Yes, here. So this is during, type check one inductive, whatever. But yeah, so when I was adding the invariants, I noticed that it was very difficult to figure out why this expression is type checked, and I believe it's because it's not. We basically don't do this conversion check, and then we go on and we call some other functions that happen to type check it. So that's not very good. But the good news is that later we have to check that the parameter indices exactly match, which means that we sort of will accidentally catch this, and so it can cause non-termination, but I don't think it can catch anything else. So it's not that bad, but I'm pretty sure there's other stuff like this, and some of it's probably more serious.
You could craft an inductive declaration that makes it.
Yes, pretty easily.
Probably not from the source syntax, because it's out.
That's one problem with the checker, is that every single view file we ever produce comes from the kernel. So if the kernel has no bugs, then there's no way to generate some kind of mischievous view file.
But yeah, it's not just the kernel. Is that not only we run it on VO files produced only by the kernel, but usually the only way we produce those VO files is using input syntax.
Yes, which is
and on this particular example, I wouldn't bet the kernel doesn't also have this forgotten check. But it doesn't mean that we will generate a VO file that is problematic with the current infrastructure. But basically, we're not testing it.
Yeah. Right.
So what do you do on primitive projections?
Currently? So this is actually based on the 8.6 kernel. As I understand it, the checker for 8.6 doesn't really handle primitive projections correctly.
Yeah.
I don't actually have the particular bug that was failing earlier, but that's only because I think I hadn't even implemented enough to have that bug. But
did you say 8.6?
Yeah. Yeah, because I started working on this.
Primitive projections were introduced in 8.5.
Yeah, but the checker.
The checker was not adapted until later.
Yeah, it makes some token effort to deal with them, but it doesn't really do it correctly. And the checker, I think, still doesn't really check some stuff that you think would be good to check for primitive projections. I don't think the checker actually checks the projections have to have one constructor or anything like that. So there's definitely other issues. I'm sort of illustrating the most egregious one I think that I've found so far. Other than, I don't know. I was looking at modules and I couldn't figure out any invariants, but then apparently, that's a separate discussion.
We should talk about that, by the way.
Yeah, we should talk about that, but probably not right now. So this is to say I have not implemented modules yet. Okay, so anyways, so the other place I wanted to show was, here. Here. So I'm sure you're all familiar possibly with this loop in the production machine.
We can fix me. The check for interrupt line is necessary because this tends to be a tight loop. So that's where we detect if the user wants to interrupt the computation.
If you,
is that not very satisfactory?
I guess it's just going to raise an exception. I guess you don't want the checker to be rerunnable anyway.
Yeah, is it really?
I don't think the line is in the code of the checker.
It has to because it's a computer kernel.
Well, it at least was in the code of the checker when I wrote this. I think a lot of
just move it. I think.
Yeah.
I don't know how the checker handles interrupts. So it will raise an exception. Does it raise the
I don't think there's a hand up for.
It's this. It's
But
this
anyway,
one.
it's hard.
Okay, you can remove this line.
right. Well, the checker is full of many mysteries.
Yeah.
but this one, right. So anyway, there's this loop. It's because due to the sharing, one side in reduction can reduce to in weak hat normal form. You go to the other, you reduce it, and now the first one is not in weak hat, so no camelidus loop, which I don't think anyone has really demonstrated the sound. And apparently also can cause some pretty, sometimes is not good for performance, I think you said, actually.
Yeah, so
You said specifically during conversion, it's not always the right default. In any case, so in the Rust, I took advantage of the fact that I sort of have to know anyway where all the sharing is, discovered that there aren't that many resources shared. So I actually split them out between the two sides and I run them in parallel. And this is actually only this is sort of the trickiest place to parallelize, I think, but there's actually a lot of room for parallelism within any, checking any definition. In particular, during type checking, you can basically type check in any in any match statement. You can type check all the branches simultaneously, and a few other places, and fixed point arms and stuff like that. So in practice, I think once I actually go and add parallelism and maybe switch to the optimization that Kara already did with the change in data structure, so I don't use an array, then it should be possible to parallelize a large portion of the checker, which hopefully should make it less bad that we basically aren't sharing in those cases where the sharing would be beneficial. So I haven't actually benchmarked this yet. I actually haven't been able to test it because there's a lot of code to write. I'm almost done, except for that the modules sort of need to be in there before I can actually check a real file. Yeah. But hopefully this should be pretty quick because you can use a thread pool and it's pretty short to send messages here. I'm also using a sort of neat Rust type system feature to allow continuing to sort of do the shared mutability within each thread. So in Rust, normally you have to make a lot of really unpleasant trade-offs if you ever want to perform interior mutability. Usually you have to use atomics if you want to do stuff between threads. But in this particular case, we always update it in a single-threaded way. So it doesn't really make any sense to use an atomic. So I created this cute little API that just allows you to basically transfer around a token that gives you access to all of the, essentially all of the terms within a given arena. Since I use an arena because Rust doesn't have a garbage collector, I didn't want to use reference counting because I don't want to be slower than the OCaml implementation, which I think is still a possibility. So that allows us to lose very little overhead over OCaml and should hopefully, again, help make sure that this parallel solution is competitive. So I think that if it turns out that the parallelism works well, it would be a very good approach because you can get a lot of cheap performance that way and you don't have to sort of mess too heavily with the algorithm, which is much trickier. Let's see, so some other things. I think I've been a big stickler for checking for integer overflow here explicitly, and the dream is that eventually we can essentially collect all the integer overflow errors at the base and then switch to a big int representation if it fails, so that we don't actually have to pay for the big ints unless you really need them, which hopefully no one will ever actually will, but we still preserve correctness in that case.
Sorry, I missed what integers you were.
So I mean, since OCaml uses machine integers and does lots and lots of arithmetic, there are many cases where it's very unclear to me, or that either very unclear to me that it can't overflow, or very clear to me that it can. Currently, I think it usually doesn't because it will run out of some resource, but I don't think that's particularly guaranteed. That's sort of an implementation detail, and like.
So, what concrete examples do you have in mind?
Places like this. For example, when you perform a lift, you can pretty easily generate terms that will just keep lifting and lifting and lifting. And you can overflow that way. And I'm actually using, I think.
Usually from binders, right?
Yeah, yeah.
You probably need to allocate cells at some point.
I mean, yeah, but like that's.
Because the question is not whether you can overflow in theory with infinite memory, whether you can cook up such terms without allocating so much that you're never going to reach that.
I mean, people have a lot of memory these days. So I actually think it's probably possible. I think the thing that's actually not allowing it to happen right now isn't memory. It's the fact that some operations are done in a non-tail recursive way. So you run out of stock. But I'm not convinced that that's the case for every operation that can overflow. But in any case, if it turns out that in practice these don't ever overflow, then that's fine. And we just never use the big ints, which would be perfect. Because I don't actually want to use the big ints. I just want to, I want to make sure that its Coq actually operates on natural numbers.
It would be nice to try.
Yeah. I mean, I'm already catching all of the overflows, so like that's kind of the annoying part, is handling those explicitly. Let's see, other places. Oh yes, so I'm using a weird, annoying, stupid persistent data structure since I'm not using the fully persistent maps because those are, or vectors because those are actually quite slow. So I created like an undo log that I can use for places like universe checking. So the idea is that when you want to check some universes and want to merge them with the existing set, you, as you push them in, you add them to the undo log, you perform the operations, and then if you do want to roll them back, you can. So it's not really very complicated, just a difference.
So I understand this technique, but when do we need to undo the addition of universe constraints?
Yeah, for universe polymorphic types or constants, because when they're polymorphic, you don't actually add them to the global constraint set. And hopefully in the future, all or almost all inductive types should be polymorphic, so that means this should happen a lot. Yeah. Let's see, I think I have, oh yes, so a few other notes. Right, so I was able to figure out how to leverage some existing deserializers to handle the OCaml VO file format. So this actually can handle any OCaml binary format. You just sort of write the OCaml type in PROZIT, which is nice. It's saved a lot of time. And it also, make sure it doesn't do needless work and like preserves shared references, since otherwise there's a really, really large size and time blow up, like hundreds of times. Let's see, is there anything else of interest? Yeah, I think that's most of it. So anyway, as you can see, I've implemented through inductive types. The only stuff really left is like module stuff and the guard checker. I have done the strict positivity check, but not the guard check. because it's Unpeer's advice. But I think I might actually end up implementing that before the module stuff, since I kind of don't want to implement something that doesn't work. And yeah, so, and hopefully some of this will be faster. I don't know.
And do you plan to prove the correctness of this at some point?
Yes, at some point. I've been starting to work on some stuff, but yeah, obviously the current implementation is not really proven correct either.
Yeah.
But I think certainly some parts of it that are like kind of tedious and seem error prone, like a lot of the stuff during inductive type checking, could use a proof. Whatever module system we end up replacing this one with should probably have a proof for at least some definition of its substitution operation.
Yeah.
And yeah, and a few other things. Like I think really a lot of it should be amenable to proof. I'm not sure exactly where the Gradelian restrictions are going to come up, but I think most of it should be doable in Coq. And I know there was a project a while back by Bruno Arras on something like this, but as I understand it, that has sort of been not gone anywhere for a while. So
yeah, and it's on a model. So we are doing this with a template Coq now. We have formalization of the structures of the kernel, and we are gradually trying to verify the different purely functional specs of the reduction, conversion, checking, addition of and the guard check. So Cyprien is working on the formalizing the guard in Coq.
Yeah.
So I guess you could, ideally, you could be able to, would be able to link to our spec, to the functional spec to this implementation.
yes.
Did you say Cyprien was working on formalizing the guard condition in Coq?
Yes, that's what he said. Yes.
Well, so it would be good to,
Well, yeah, but I'm saying it.
it's very work in progress. I mean,
we are really at the beginning of it. But,
if Cyprien is also not aware that he's doing it, then it's fine that we are not.
He's aware.
I think I'm aware, but it's a very start of it.
Please communicate even before starting this kind of effort.
But we are still at the regular trees, we're not at the guard check yet.
It's not completely forbidden to be organized collectively. Sometimes.
I'm telling it to you. That's the first time I get the opportunity.
What is the current status of modules? I mean, functors, more specifically in the Rusty checker.
This one?
Yes.
I mean, so I just get stash in case I'm sure you get unstash, at which point you won't be able to compile the code. But yeah, suffice to say that I'm sort of about halfway done, but I'm very unhappy with it.
I'm asking because functors is the only place, to my knowledge, where the kernel and the current existing checker really don't do the same thing. On purpose, as opposed to by accident of copy pasting code. So I was wondering which of the two behaviors you want to do. So basically, the OCaml checker defunctionalizes all the code. So do you want to do that, or do you want to implement the same support as the kernel has?
So I'd really rather not do what the kernel does, because what the kernel does is actually significantly more complicated. And also, I think by the time these structures get to the kernel, they should already have certain invariants. So I would be re-implementing a lot of code that didn't actually do anything, hopefully. I think that so there are a few reasons why I want to sort of wait on the modules. One of them is the fact that the checker is currently doing something weird, but also I think the way that it's done in OCaml doesn't play so nicely with the lifetimes that I've set up. Basically, so I've been using invariants in a lot of places. I'm able to just reference back to whatever the thing I parsed was and not copy it. And I would like to be able to continue to preserve that, because among other things, it would make it a lot easier to integrate into the OCaml implementation, since they could just hand out a reference instead of having to like waste a bunch of time copying things. However, during module checking, occasionally, basically everything, including inductive types and stuff like that, are copied and subtly changed for strengthening, and as a result, don't have the correct lifetime. There are a few ways of dealing with that, but I think from looking at the code, it should be possible to reorganize the files so that you just don't need to copy at all. So I'm going to try doing that. But like I said, I found that trying to actually implement the modules in this way was somewhat tedious, and then I tried to prove some stuff about them and I couldn't, and then there were a bunch of bugs. So I think I'll work on the garbage checker first. And, I do have like the inductive. I have inductive and constant checking. I just can't do anything complicated with modules, basically. So maybe I might just sort of skip functors for a little bit and just do like the other stuff just to get something working.
Yeah, let's mention the spin-off of this.
Can you come closer to the mic?
Sorry. Just mentioning the spin-off of that work, which is that we're trying to come up with a rather more principled presentation of the module system in some theoretical basis. So hopefully, so yeah, we need to gather everybody with goodwill to help us in that task. So yeah. Like,
so that would be Derek, you two, me. Yep. Maxime, if you want to have a look, you're welcome.
I can try to find bad examples.
Yeah. Oh, we know some. We know the questions. I mean, there's also, Jamali told me a little bit about this. There's also a project of trying to change the way modules are elaborated right now, so that the kernel gets a more complete structure and it doesn't have to do inference or subtyping and things like that, just checking. So probably that's what you want to implement and what we need to model. But I don't think we really looked at the details yet on what is the plan there. Maybe you know, Caroline?
I don't know. Cool.
I always found it very weird that subtyping is checked only at the end, for example. Like interactively, we don't use the fact that you add a signature to say, oh, you're defining with this field of the module, but it will never be a subtype of what you declared at the beginning.
It's very strange.
The phase distinction is
there's a bug report that actually people want the upper layer to be aware of that because you know the type you're going to inhabit. So
yeah, and it's going to simplify the kernel as well.
Yes. Yeah, but that one's more an implementation side. Yeah, that would be already. But actually, that would make that. Yep.
So just to wrap up on. There are so many open problems related to modules and functors to also include, and that breaks the quick compilation chain and many other things. The canonical versus usernames, all this stuff. Whether we could defunctorialize outside of the kernel or not. So it would be really nice to try to come up with a clear plan. I mean, and maybe not address all those problems, but at least be sure that what we are doing is compatible with the
grand
global
scheme.
I don't know about this actually. What is the problem with include and quick compilation?
So the problem that include today works by copying structures, and basically that's one of the huge contraction as well. So you can copy bodies of opaque constants, things like that.
This is the implementation. Then of course you could just copy it by reference and say it's like that one, but it's not implemented this way. So it really makes a verbatim copy of the proof term. So
that's so strange. Because there is support for these kind of mechanisms in the module system already, right? And module aliases.
Yeah, but it's not doing the same thing because you want them to be really equal. Yeah, it's actually defining an alias, but not quite the right way.
So I've thought a lot about all this stuff, and I looked at history, I did some archaeology. So I have a pretty good view of the think, the global problem. And you would be surprised how many of those design decisions were taken because of the behavior of tactics. This is the main motivation in most of the decisions.
Yeah.
So said otherwise, any naive view on we're going to change the formalism that doesn't also come with a significant amount of time to invest on making tactics compatible with the evolution of it's going to fail.
Yeah.
Like all the other previous efforts.
Yeah, right. But
the reason why we have canonical names in the kernel is because tactics didn't support the various matching algorithms in tactics didn't support aliases modulo delta. But there are many such examples.
That could be moved outside of the kernel.
Not without working on tactics.
Yeah.
Yes, right. What I'm saying is that we should. Yes.
So
you cannot work in isolation from the rest of the system.
Yes, I don't think
exactly. Especially when you evaluate the resources that you need to carry out such a project, you should take into account that you need to maintain.
I believe.
Yeah.
No, I guess.
So I have another meta question in some sense. So we have a checker, and it is an added value to Coq because we can kind of claim that we have yet another tool to check the proofs. Then we also know that it's sort of a lie because the current checker even shares verbatim some files with the kernel, so it's not really an independent checker. Here, I missed the beginning of your talk, so I don't know if you said it, but how did you write it? I mean, because we saw a line coming straight from our kernel.
Yes, you should see a lot of lines.
Check for interrupt. Is it independent or?
Yeah, I even found the sentence that you pronounced at the beginning of your talk a bit misleading, or I don't know how to say. So you said like you mixed the fact that it was a re-implementation in Rust with the idea of an independent checker, and I think the two are more or less unrelated. To me, the fact that this is re-implemented in Rust is a good thing for the sharing part and making sure we get this right and so on. Yeah, but it doesn't mean it's independent. I hope this happens to also be independent. But
for example, I trust the runtime of Camel. I don't trust the algorithmics in the reduction machine, for example. And here it seems that you're replacing the runtime of Camel with the smaller runtime of Rust, and it's type theory that is nice. But still, the algorithmics, is it the same or?
It's mostly the same.
Mostly the same.
Yeah, I mean, there's actually a lot of stuff I would like to change, but I wanted to basically do a straight implementation first, since, well, really for two reasons. One, because when I started this, I didn't actually understand any of the Coq internals, so starting to re-implement things would have probably not ended well. I actually did. There are a handful of things that I changed algorithmically from the OCaml, and it didn't always work well because actually, surprisingly, Coq is actually pretty optimized. So that was one reason, and the other reason is that I was aware and continue to be aware that the amount of time that this is taking means that Coq Checker will continue to add features. So if I have something that's relatively close to the actual Coq Checker, it shouldn't be so hard to add them because I can just look at the diff. But if the file is like completely different, it is not going to be very easy to figure out what to do. So those were largely my motivation here. It still ended up not being quite so easy to copy paste as you would think, tail recursion or tail recursion optimization. So
I think it's fine to sell this as an independent effort, but and it's very good for the stress to show that it's independent should be put rather on the comments and the questions you had about invariance and the things you looked at, rather than the fact that it's a re-implementation in Rust. Right. I mean, this is the part where you had an independent look at the logic behind the existing implementation. And this is where so it's very good, I think.
And you could also have a different version where you do change the things that you
Yeah, I mean.
Now I have a very tricky question. So imagine we are. I find this very, very nice. We have not only an independent implementation, but also in a language that makes it easier to express invariance of the tricky bits in the machines. How do we maintain this? So the problem is, how do we maintain this while maintaining the independence?
So, I mean, I think the question could also be asked of the current checker, because it's very unclear to me that it actually is being maintained. Like stuff gets sort of ported over at first, but then it doesn't always get updated.
Yeah,
but right now it's sort of it's easier to sort of try to keep them in sync, I think, because they're both in the same language. But I think that what's really needed here, as was alluded to earlier, is actually some way of performing tests on both of them, and actually testing like invalid stuff against the checker, which right now never happens, which requires building up some tools to actually do that. I know, Pierre, you're somewhat skeptical about what causing will find, but it would still be a lot better than what we have now, which is absolutely nothing.
So that would be good to make sure that the new checker still covers the entire framework, logical framework, but it could also endanger the independence. Right? If a way to perform operations at the same time in the kernel and the checker could be read as if I make a mistake once, I get to copy the mistake. You see, so.
No, but it has to stay independent. It has to be someone else who implements.
Yeah, but I mean, like
modification to the checker.
Like there has to be. I mean, to me, like the question you're asking only really makes sense if there is some independent spec. Right now, parts of Coq have an independent specification, sort of, and lots of parts of it don't. So I'm not saying that like the algorithmic details should be the same in both of them or anything. Although apparently sometimes people do realize one is for performance or whatever. But like until like at least the major parts of the kernel actually have some clear specification with like tests and proofs and so on that you can actually compare it to an implementation, I don't really see how you can feasibly keep the checker completely independent from the
kernel. We cannot compare the implementations. We should have a spec to compare both of them too, and then they can be really independent.
Yeah, and I mean testing isn't perfect, but at least if you run the same tests against them, you have something shared that isn't like looking at each line of code and deciding whether it's the same. So I think that's sort of my answer to that question. And I think this applies equally to the kernel if it remains no count.
Yeah.
Or checker rather.
All right. So thank you. It's very nice work. So we have two problems for the program now. One is Mathieu needs a small break, I guess.
Yeah.
We are late. The other one is the next speaker is Emilio, and I didn't get any news from him. So maybe we can solve both problems by taking a 5-minute break while I call Emilio to see if he can do the talk.
And what's the next one otherwise?
Sorry?
What is
it's Enrico.
Okay.
On attaching data to goals.
Ah, yeah.
Again, I think that I can explain the thing, but Emilio was the one with more doubts. So
yeah. So
I have doubts too.
Okay.
Needs to be special, isn't it? First time.
Do you want a coffee?
Mathieu?
Oui.
So if we can't get Emilio, I guess plan C would be to discuss primitive projections before lunch instead of after.
I would prefer after. Like I'm not ready yet.
Okay. Then let's find plan B.
Yeah.
Oh non, c'est bon, on a eu.
c'est effectivement. Ah oui, t'as raison, ok. Alors, comment ça se fait?
But tu vois, c'est maybe
Ah, doit être irrévérencieux. Ça, c'est. Ouais, pourquoi est-ce qu'il. Attends, attends. Quand je fais juste ça. Parce qu'elle est capable de la voir.
Là, c'est encore.
il n'y a que les désarts aujourd'hui quasiment.
Oui, c'est ce que je me disais.
Excuse-moi, je pas les choses.
Enfin, si, il y a Enrico et Maxime.
Ouais, mais je veux dire ici.
Et ici, non. Oui.
Après la série des arts, c'était peut-être un peu.
Non, il y a ici aussi. Et Yves.
Je suis flattée,
Quoi?
Il faut couper le micro, hein, si vous voulez.
Ouais, c'est
ça sur la
Mais non,
c'est Maxime, il était intelligent avec le micro avant de dire du mal.
Et Vincent, non, mais c'est pas ça que je voulais dire dans le sens. Comme ça, on peut.
Non, là, j'ai le micro, c'est bon. C'est quoi ça?
Pas moi.
On a le micro.
C'est quand même pas facile d'organiser cette
Ça
sorte de
doit être retardé.
On a le micro.
Ça doit être.
on n'a pas coupé ton micro.
Quoi?
Je sais, allumé.
Ah, on l'a rallumé là.
C'est parfait. Parce que pour l'instant, j'ai vu que c'est juste très intégré. Dans le troisième, c'est ça, c'est la retraite de. Enfin, c'est la retraite de. Un truc comme ça. Et du coup, Pierre sur la table.
Le micro était
allumé, je sais bien.
Et on est sur YouTube aussi en direct.
Oui, bonjour la planète.
Moi, j'ai pas dû mettre des vidéos, je pense qu'on a peut-être mangé du coup.
C'est notre façon de résoudre les deux problèmes d'un coup.
Ouais.
Il va vraiment attendre de préparer la discussion pendant le déjeuner, Mathieu.
Mathieu est pas là.
J'aurais eu besoin d'Emilio pour les blockers aussi. Parce que.
Il a mis beaucoup de blockers.
Ben oui. Enfin, non, c'est pas que lui, c'est un peu tout le monde. Il en a deux, lui.
Oui, tiens, combien on a de blockers? C'est
14.
ce qui est marrant avec ça, c'est que les gens aiment bien les mettre, mais personne ne s'occupe de les résoudre.
On n'a pas vu beaucoup. C'était marrant.
C'est que les gens aiment beaucoup les mettre, mais personne ne s'occupe de les résoudre.
Oui, mais l'adjectif que tu as employé.
Ah oui, c'était marrant.
Nous, c'est une façon de voir les choses. J'aimerais bien.
Attends une seconde. Comment on peut avoir des feature requests qui sont des bloqueurs?
C'est quoi la feature request?
Eh ben, il y a deux labels. Il y en a des montées-souris qui permettent de cliquer plusieurs fois.
C'est ouais, mais c'est l'histoire d'instance. Qui a mis le bloqueur, par exemple là? C'est Emilio.
Je sais que hier, j'ai pris un exemple, j'ai dit ça vraiment, le mec qui a mis le bloqueur là, il a fait la question. J'ai regardé, c'était moi. Mais ça, c'est Emilio.
So you didn't get any news from Emilio?
No news from Emilia. So since Matthew was planning to prepare the primitive projection discussion during lunch, I guess the only plan ahead now is to have lunch now.
It's a bit early.
Okay, the rest of the discussion really needed Emilio, except for the primitive projection part, but that one is not ready. So I'm not a magician.
But were they supposed to come here or?
I think so.
All right.
So about the blockers labels, I think the most part can be solved by just removing the blockers instead of fixing the bugs. Too
I
many.
think that's often true.
Too many.
Hugo is not around, but
yeah, there is a PR to revert.
There is a PR to reverse, but we need Hugo to be around, I guess.
No, I don't need Hugo to be around to revert the PR.
He needs to handle it.
You mean annotation scope one?
Yes.
Yeah, you just revert the PR and then you ask him a new implementation. No?
I think he mentioned reverting this at some point.
He said something like that, yeah.
But anyways, this is not going to be fixed in time for 8.8.
I don't think so either.
So there is more than one thing to fix.
Yes, there are two bugs with this PR.
I think we should understand how it happened. That despite our review process, we merged a PR that had an open problem. What should be done for aliases in the commit message? I mean, merging a PR with an open problem.
How many commits were there in the PR?
8 and 3.
It's not so hard to.
Josh, the code of your checker is on GitHub?
Yes.
Is it?
Is hold on.
How,
It's
is it named what?
It's Kravenan, and the branch I'm working on is spelling this correctly. Yeah, I'm not. Okay, well, anyway, it's Pure has it as well.
You should probably send it to the.
Maybe you can send a link on Gitter.
Okay, sure. I can do that.
They don't. Yeah, the branch I'm on is WIP. And characteristic merges it into sporadic. Yeah. Yeah. Anyway, the invariants, there are more invariants as you go further down the code because I originally wasn't writing enough. Now I might be writing too many. So I don't really do that.
So I think one proposal would be to go to lunch now. Because Emilio isn't there,
Nowhere to be found.
and nobody wants to talk.
So there are, I mean, okay, it's easy. I think everything would almost require Emilio's presence, except for the primitive projection discussion, which is more like Pierre-Marie, what you and me.
Yeah.
So if that's not ready, I suggest we have lunch now and we resume at 1:30. That's the only plan I have.
How we discuss primitive projections. And I wanted to make slides and explain my position on this, but it's pretty easy in a sense.
Yeah, so
the
I'm
idea
fine
is
with
just
having the discussion now.
Yeah.
Do we want to have it now?
Yeah, we can.
So do we aim for 30 minutes? What was it on the program?
Yeah.
All right. Good now.
So the thing is, we so there is a question of what do we how do we represent the projections in the kernel? So currently it's a constant plus an unfolding flag, and if we want to remove the compatibility layer, we could switch to just a kernel name for the inductive and the number of the projection. And that would be the most natural representation of this. It would be dual to constructors, and it would simplify the reduction as well. Because right now we need to look up in the environment where the projection is defined and which index of arguments of the constructor we need to project.
Yeah, but when you said the compatibility layer, there are actually 2 layers of compatibility layer. I'm not sure about the role. And so one is about the kernel name that is a constant, and one is about the unfolding Boolean.
Yeah.
I'm not quite the same. You could imagine a setting where you have one but not the other.
Yeah.
So the unfolded Boolean, I never really understood why it was there in the first place.
Yes,
so maybe.
So maybe I can tell you.
Can you give an example where it's needed?
So it's needed if you want to do you do CBV delta, and then you do separate. After that, you do CBV iota, and that should unfold a projection, right? Because a projection, a usual projection defined by a constant, needs both flags to unfold, right?
So you mean the elaborated projection usually needs both delta and iota to reduce?
Yeah.
Okay.
So to preserve this behavior of needing both reduction flags, I needed that flag to distinguish a projection which was delta unfolded and iota reducing the unfolded version. You see?
So I understand in the abstract, but I don't understand where it comes into play in practice.
So you are writing something with tactics, and you just do CBV delta first, and then you do CBV iota, and then a reduction should unfold.
I mean, the question is.
But it should not unfold if you just do the delta, right?
But you see the difference only if you already exposed the primitive projection as opposed to the compatibility constant. Otherwise, it would also require a delta step. I'm a bit lost. You're saying, so I disagree with that. Okay.
Why?
So previously you had the constant.
Yeah.
And you need to do one delta step to get a match. Then you need a iota to reduce the match.
Yeah.
That was an old setting. New setting. If you start from the same thing, you have a constant.
Yeah.
You do a delta, it unfolds to a primitive projection.
With an unfolded, so the constant body unfolded primitive projection.
Yes, but so you're saying you don't start with the same thing and you don't see the same behavior. So of course.
No, you do start with the same thing. I mean, by compatibility.
In both cases, you start with the constant.
Yeah.
So in one case, it unfolds to
a match.
In the other case, it unfolds to a proj.
An unfolded proj, yeah.
A proj, I mean.
Yes, when you unfold it, that's the point.
Yeah.
What would you need all projection?
Imagine you don't have it. And then you need iota to reduce either the match or the proj.
No, yeah, okay. So what you don't see is that the idea of the compatibility layer is that if you use a constant, the compatibility constant or the projection, the folded projection, they should behave the same.
But I think that's the mistake.
Yes, I think so.
Why? They are not the same thing, so why would you expect them to behave the same?
Except that the user doesn't see the difference because printing is.
But that's the second mistake.
Yes, that I.
But then you remove the compatibility layer.
Yes, right.
No, but it's not exactly the same. Yeah, okay.
I think it's the same thing because if you have the projection is partially applied, you will get the compatibility constant, and if it's not partially applied, you will get the real primitive projection. So from the user point of view, it doesn't see why there would be a difference between the two.
So right. So once again, I understand in the abstract why you need that, but I don't understand in practice why we want to be like one-to-one. Like you have a new feature that is not like exactly the same thing.
That was a choice. That was a choice to satisfy Jason's needs.
Yep. I think I understand where my confusion comes from. What is the point of the compatibility layer? What is the goal? The purpose?
To make it to make developments compatible whether you have primitive projections or not.
But that is not the case because they are behaving.
But then it's not what you did. So so if that's the purpose, why didn't you just have an explicit syntax for primitive projections, and then compatibility constant that unfold to either a match or those projections, depending on the value of the flag, and that's it. You take code that is compatible, that works without primitive projection, you turn it on, and it still works. If that's the purpose.
to make it work, you need this unfolded flag. To make it work, I mean, it does not. It's not even perfect.
No.
But to make it work in all situations, I don't see how you could do otherwise.
No, but
I mean, the
kernel has to.
It seems to me that there are two different purposes that could be pursued, but are not the same. One is you had existing code that was not using compatibility, that was not using primitive protection.
Yeah.
And you want that turning it on doesn't break it.
Yeah.
Which is not true already.
For this, I'm convinced you don't need the unfolded boolean. I'm convinced.
Well, how do you do otherwise?
But it's broken already.
But there is no reason why a primitive projection will show up in this development, even if you turn primitive projection on in the first place.
They will. Because if you okay, so if you want to benefit from primitive projections, you have to elaborate fully applied projections to primitive projections.
Why?
Well, otherwise you don't benefit at all from primitive projections.
Otherwise you get parameters.
And here's the real purpose of the compatibility layer, which is not the one you just said. The real purpose we pursued, which is another one, is to make existing development
benefit from it and be compatible.
Primitive projections.
Of
which
course.
is not at all the same purpose. But then it's not a compatibility layer. It's an optimization layer or whatever. But usually my point is I think this clarification is fundamental for
it's your point.
To agree on a new design.
Yeah.
Because usually when we talk about compatibility layers in Coq, we mean what you said, not what you did. We mean it shouldn't break existing code. Dot. And make it available for new development to use. But this idea that they could magically benefit from the new implementation, this is something very specific to primitive projection. And this is the root of all the problems I saw on the
And it doesn't work. Like turning primitive projections on has other consequences that are not backwards compatible, like name generation for when you do destruct and the like, they're nothing to the same.
So, and then attaching eta to this,
and that we should cover later. Actually,
this we should also discuss, but it's a bit orthogonal. So my claim is that if the goal is just a compatibility layer, as in existing code not using primitive projections should still compile, you don't need the unfolding boolean. You don't need that because you will never have a prog in the first place. But in this design, you have two ways to write a fully applied projection. Either using the constant or projection syntax, and the two are not the same. So I don't know if you want that, but that's one possibility.
Yeah, that's.
But what I'm sure is that for printing, you want to distinguish both.
It's a real mess. The current situation, like when I use personally for the primitive projections, there is no way to tell. Like you get random bytes because they're not the same. They're unfolding, not unfolding, blah blah blah. It's a real nightmare.
But do we agree to stop pursuing this purpose of making existing development magically benefit from the?
I'm fine with that.
So then it doesn't mean, but my point is that then the unfolding boolean can go away.
Yeah.
But then there is another question, which is, do we want to keep the notion of to?
I mean, a priori from this point, I mean, if you do that, you could do this outside the kernel.
Something that would be very nice would be to forbid writing projections when you're actually not writing a primitive projection, like having a flag that says, like you write dot parenthesis something, that this thing shouldn't be elaborated to an application.
Well, we need to agree on the syntax as well.
That's not because people do that already for applications. You can use it's a bit weird because I think the printing of projections is disabled by default. So this dot notation is not used by default in Coq.
Not anymore since the batch by Maxim.
Okay. You may.
It's worse than my patch makes it that when
only...
you use set printing all, it prints dot parentheses for primitive projections and only for primitive projections.
Yeah.
So you can distinguish.
Yeah.
But by the way, I don't understand this syntax. Because I thought for a long time, I thought it was parentheses around the record and then dot and the name of the projection.
No. It has always been the other way.
Then I realized the parentheses, and I thought that because you can have a composite expression that builds a record. But projections seem to have just a name.
Yeah, I know it's great.
But you can't do that for parsing problems. Like there is no syntactic difference between uppercase and lowercase. So you cannot tell whether something is a module name or.
Yeah.
That's the main problem of Coq compared to Camel.
I thought about it, and I think it's not true for this specific example that you can distinguish. I mean, you can distinguish. So what?
So what?
But you can parse it. You can parse it.
You can parse it, and you know whether you're actually referring to a qualified name or a record projection.
Yeah.
Not the same thing.
Yes, but there is no parsing problem.
No, it's not parsing. It's interpretation of what the user wrote.
Sorry, I thought I heard parsing.
Yeah, but it's yeah, right, okay, fine. But it's linked to parsing, but you cannot statically discriminate between a projection and a qualified name Coq. And there is just very same
at parsing time.
At parsing time, yeah. But even that, like you could have an ambiguity. You could.
Yeah, but that's fine. That's completely fine. But let's put the syntactic discussion on the side. It's just to say that I mentioned it only because the option you suggested, which makes sense, makes sense only if we take the same syntax for primitive projections and
so
projections.
Actually, what you did also helps resolving the compatibility issues, because one thing that's hard is if you do syntactic matching in the goal with P applied to underscore, I don't know. What should match? Just the primitive projection or just the constant or both?
Yeah, well, there are many. I think if we agree the unfolding Boolean can go away, the next thing to decide is when we use an applicative syntax as a user in a new development that has primitive projection turned on, blah, blah, blah. What should it do? Should it? So there are many. Okay, there are many things that we can do. We could still generate compatibility constants.
Yeah.
But the kernel wouldn't do anything specific about it. Yes. So then we could use the applicative syntax, but the parameters would be there. It's not optimized.
Yeah.
So, full design. We could just not generate the constants. I don't know. Do you have thoughts?
I would be for a cleaner design where the projection is written as a projection.
Okay, so no applicative syntax.
Yeah.
Well, the user can still define the.
Yes, you can do that.
Maybe probably even with just a notation.
I haven't thought about it. So
because
the
it's
notation could drop parameters.
You could do that, yeah. That would be a bit strange because you could write terms that magically disappear from the algorithm things, and that could be nonsense. But yeah.
But in fact, it looks cleaner to do this as a notation. So that
the passing on notation.
That's a good idea. Well, at least. In fact, it's surprising that you didn't go this route.
I think we thought about this. Or you could even force. You could use a cast to force that the parameters are the ones specified by the user somehow. To make the notation reversible, if you want.
No. How do you turn that into notation? Because you cannot. It depends on the name of the constant. So it would require, because the number of arguments is going to be highly dependent on the constant. So you need to know. No, I don't see how you can do that. You cannot qualify the application either. Like, not gonna work.
Why?
because for instance, if you write, say, n dot p applied to something, then if I write exactly p, that's going to work. But
the qualification won't work.
Yeah, it's going to be adding a row to the parsing engine to tell, oh yes, please replace syntactically that thing.
Yeah, right.
So apart from completely clogging the parsing rules with the random shit,
yeah,
it's also not working at all in general.
But what you could suggest to users is that if they really want the applicative notation, they can use it. They can do something like this, or just define the constant themselves.
So I guess it's still a bit open whether we want to pre-generate those constants or not.
Yeah. I mean, it's fine to leave the code as is. We can do this on the, instead of doing it in the of associating the constant and the projection in the kernel, we just don't do that, but we still generate outside like we do today.
I don't understand why we do that in the kernel. Like which part of the kernel is actually relying on that?
Well, I find it nice because it's the only example of a cyclic dependency that I know you can construct.
Yep.
Yeah.
So it's always good to have it at hand when you work on proving false.
Yeah.
Interesting. Because the constant has a body that mentions the constant.
Yeah.
But yeah, so what prevents us from removing it from the kernel? Like, where are we going to face any kind of trouble? Like, I don't see any actually.
No, I don't think we.
Only the prototyper needs to be aware of that.
Yeah. I think I even have a branch somewhere where I change the representation like I was saying by saying it's just a reference to an inductive and an integer for the number of the index of the projection, and it's fine. It breaks some compatibility, of course, but it's fine. And then it's a lot simpler. When you declare a projection, it comes with with the inductive type itself. It's also cleaning up the way you declare projections is fishy right now, I think.
Very fishy.
Yeah.
Okay, so
because you need to both declare it at the time you declare the inductive, but the constant it refers to has to be declared on the side.
Yeah, and there is a cyclic dependency problem.
Yeah.
You should type checker to type check the constant before adding it to the end.
So it's super weird.
I never fully figured out where the loop is. There must be a hack somewhere.
And assumptions has a special case for this. Because
how does the kernel let you do that?
Yeah.
How does the kernel let you add the constant in an environment, a safe environment, that refers to the constant you are adding?
It's not using a safe environment, I think. The term typing is only using environment.
Yeah. No, the projection constant body is elaborated in the kernel. So it's doing an unsafe. It's in the unsafe world in a sense.
But safe because the kernel is correct.
I see.
So currently you have two ways. When you declare primitive projections, you declare in the inductive that it's a record and that it has this and that projections. And just after that, you add projection entries, which say this constant should be defined as the compatibility constant for the projection of this inductive at that index.
But what prevents you from cooking up such a projection entry with crazy info?
On what? Well, then when you check the projection entry, you check that indeed the inductive has a projection for that index, and so on. But you could do multiple. You could, for example, define multiple compatibility constants for the same same projection.
Anyway, I will sleep better if this goes away.
Yeah, me too.
So what are the remaining? Yes. maybe I have some questions on why is it bad to do a match on a primitive record? So this is naive, but I never found the information.
Scheme is too big currently.
No, sorry, that's not what I meant. I meant you're talking about the elaboration.
Yes.
But I'm talking more about the terms. What would break if we allow a match on?
We cannot. So for some of the primitive inductive types, we have no dependent elimination. We cannot handle dependent elimination.
Conductive types, for instance.
So it's just incorrect to write a dependent match on this type. So we just disallow match in general.
I think
but we could allow a non-dependent match.
I don't think so. I think it would be in trouble for conversion, for instance. You wouldn't get the right neutral.
Yeah, you're right. And yeah, in the same spirit, well, you could looking at it from a high level. We don't know how to implement the eta conversion when we have.
For a sec, because so dependent elimination. So what is the problem with dependent elimination? Sorry, I'm taking notes. I always forget it.
Dependent elimination is not true for conductive types, for instance.
So we want to disallow it on some types.
Yes, but for but that's also gone already. So what about primitive records?
Well, for the primitive records that are in co-inductive, we don't want dependent elimination.
Yes, so then for co-inductive ones, yes, but for records
and even for records.
But in general, if you see records as negative types, you don't want dependent elimination either. You just want the protections. They're just different.
So the argument is that if you have pattern matching for primitive recalls, then you're in trouble for the algorithm, the conversion algorithm, because you get neutral terms that are not the ones that you're looking for. And the hypothesis, if you look at the conversion, the eta expansion rule in the conversion algorithm critically relies on the fact that the normal forms, the neutral forms for recalls have a very specific shape.
Yeah.
And having pattern matching breaks this invariant.
Yeah.
Okay, I'll think about it.
So yeah, if you have a co-inductive primitive record, you don't want the dependent elimination at all, so no match.
Yeah, but
and if you have a primitive dependent record which is not co-inductive, you do have eta rules. So then to implement eta rules, you don't want match either.
Yes.
So there are two distinct reasons for which you don't want it.
And you happen to have dependent elimination for a finite record, but it's an accident rather than it's a consequence of eta expansion.
Yeah.
But it's not implemented the same way.
Then I think I when using it, I found some silly examples where you don't have to probably unit. But what do you do for the unit for type? You say you don't have eta.
You don't have eta. Unit. So for unit, the current idea is to use an S prop. The only way to have eta for a unit is to have real irrelevant types, like S prop.
Yeah, but the current system, if I'm not mistaken, the current system, so when it cannot give you eta, prevents you from defining it as a primitive record.
Yes.
Is that correct?
But there is no.
No, it can be primitive but have no eta. Like for co-inductive types, it is primitive but has no eta.
But there is no difference then with the standards. What's the difference with the
only the representation?
There are no projections. Like you'll get.
Oh, you need just no projection.
So it's essentially isomorphic if you write, I think, right? If you there is just a boolean that is set to true, but you don't get any additional information. So
eta is disabled for co-inductive primitive records.
Yeah.
Co-inductive primitive type.
Yeah.
And unit, is it?
Yeah.
Right, it's not disabled.
And also inductive.
It's not disabled. It's there is no way in the conversion algorithm to trigger.
Yeah.
That. Whereas for conductive types, it is actively disabled. It's not the same problem.
Yes, I understand that. So with unit, is the problem is it really eta? I mean, eta is obviously a problem, but would it make sense to make it allow it as a primitive record still and without eta?
But then, I mean, as there are no projections, making it primitive or not does not change anything.
Yes.
I'm just saying that today, my worry is very concrete. The user of the system types. Imagine a world where primitive projections are turned on.
Mm-hmm.
There's a system, so the user doesn't even know about it potentially.
It does record unit,
and then they try to define unit.
Yeah.
And it says, "Oh, warning! This is cannot be defined as a primitive record."
No. Okay, so we could relax this and say it can be defined as a primitive record, but it does not have eta conversion.
Yes. Or just say nothing.
Yeah.
But if we are in a world where we have S-prop and primitive projections, we could say rather define it as a strict proposition.
Yeah.
And what about records that have forbidden eliminations? But not because
or forbidden projections, you mean?
What do you mean?
Sorry.
So all projections have to be definable.
But that's a bit okay.
So we
basically I'm trying to review the potential incompatibility points, right? I should have said that.
Yeah.
But this is another one. So some records can be defined as regular records, but not primitive ones when they have, for example, one projection that is not definable because of restrictions. So could we relax that in some sense? Like, could we? That would probably require to tag the inductive type with the set of allowed projections.
You could have optional. It would have not have eta because you need the projections to actually implement eta, but it could benefit from the concise projections.
Yeah, not only it could benefit.
No, you couldn't do that.
No.
Because if you're eliminating prop, for instance, how do you implement that? How do you get there? Still, if you write a non-primitive record that has things in prop that you cannot extract, then you can still extract that into prop. If you don't have any projection that allows you to do that, then you're stuck as well. It's like that code.
So if you define a record in prop with a natural number field, the projection cannot be defined, but you can still match on it to produce props.
Obviously.
Yeah. Yeah. I think really you could not in that case.
Okay, but this is a bit worrying in the view of making.
Yeah, not all records can be primitive.
That's a good point.
Yeah, but if you do that, you should do that in 2 steps. Like I think the squash type and then a record that contains something.
Yeah.
Can we talk about the warning for non-negative cognitive types in 8.8?
Yeah.
What is the PR number?
I don't think it's a PR. I think I opened an issue at some point. I think.
Yeah, we discussed it. You go about.
We discussed it several times already.
Maybe it was a hijack discussion. No?
Probably.
I think the last message by Hugo was this week or last week.
We should have a way to assign numbers to hijacks. You can point to them.
Right.
What do you mean?
When you have a first-class issue today, they get the numbers, so we can refer to them. But half of the discussions happens as hijacks or sub-issues.
Oh, but you just need to stop that behavior. You need to open a new issue each time it's necessary.
So yeah.
So before diving into that, I can try to work. It's not now, but or for the next version, I can try to work on removing the Boolean and the kernel, the constant name, if you like we said.
Did you just hijack my question? What about?
But what about the positive?
I was trying to wrap up so far.
All right. So wrap up, please. Is that it?
Yeah, I think.
Okay, fine. So I'm definitely in favor of getting rid of breakages of subject protection in the current system. So it would be very nice to warn users that when you write a conductive data type with positive things like positive contractors, then that's wrong. You shouldn't be doing that. So I would suggest a very lightweight situation that is just trigger warning in that case, saying please use negative projections and schedule at some point a removal of that anti-feature. What do you call that?
No, it's 6768. The issue. It is an issue.
It is an issue.
But there is also a PR about restoring subject reduction and other examples, I think, from Mathieu.
What, where?
Uh-huh.
But it's unrelated, right? That was the one with the forbidding fixed points on non-recursive types.
Yes.
It's orthogonal.
Well,
it's,
yes, it's a different.
That's the same ballpark.
Exactly, that's the same ballpark, but it's a different, precise issue. And so, yes, and also, just to mention, nobody actually uses conductive types in the standard library, so changing the library with the stream file, and I'm pretty sure nobody uses that in the wild. Everybody rewrites, like yeah.
So you want the warning? So I guess the question is the replacement ready in practice?
Yes.
I mean, are people? Has it been tested enough?
I experimented. I don't know if other people do.
What do you mean,
I experimented playing with this co-inductives with primitive records and doing things like they do in Isabelle, because this in Agda and Isabelle people switched to that presentation of co-inductive recently. So there's been a lot of experiments in these systems, but I don't think in Coq it's been used so much. I don't know other people. I'd like to know.
Mathieu, so we have a question. Why applies relation is conductive?
Oh, it's some standard trick that they use also in MatComp where you don't want the corrections, or you don't want the eliminators, and you're too lazy to write unset eliminations.
It's not that you're too lazy; it's that the development team that you're in contact with is too lazy to implement it when you ask. So you do otherwise.
Okay.
Try to do.
Fine.
So what was I saying?
You were saying that Isabelle and Agda is the negative view of the world.
Yeah. But I don't know if other people have tried to use this presentation.
In Coq?
Yeah.
No, because we didn't do any kind of advertising for it. Yeah, I tried to do so by writing a few slides.
So yeah, we still promise to write something about this with Chamari.
How good is the documentation, by the way?
For
co-inductive records, I don't think there's anything about this.
For co-inductive types in general?
Or co-inductives in general.
Even the recommend is not very easy.
So that's a to-do, yeah. That's what we have to do.
So I would feel better if the documentation comes before the warning.
Yeah.
But like, is it still doable for 8.8 if we do it very quickly?
Yeah.
Like writing a short paragraph.
It would be good to if we have the documentation in the beta phase, we can really advertise it to people. Then it should be good enough.
Yeah, and adding a warning in terms of software integration, not really hard.
That means we have to. That means we have to rewrite like the stream file of the standard library still, because we don't want to trigger warnings, I guess.
Yeah.
Yes.
But basically, that's one of the examples I did already.
Oh yeah. But we don't. I don't think whether.
Just this
relation is not really.
So the answer is probably it's a good thing to do. It's not there. I mean, it's not a disaster if it's not really in time for 8.8.
Yeah.
But it would be good to do it.
I mean, it would be good to get rid of sources of loss of subject direction as soon as possible. I guess.
Yeah, but that's why I mentioned the other one.
But the other one, what is the status? Is it going to get merged for 8.8?
I don't remember. Do you have the PR number? What was the?
For this one, it should be.
I don't think it's written as a blocker.
407.
Sorry?
It's 407.
In the hundreds.
Yeah, it's an old one.
And it's flagged at 8.8.
The milestone is still 8.8 beta 1, but
what's blocking? No.
I think it was never as yes.
It just
it's not doing anything fancy. It's just preventing you from. You should probably just rebase it and.
So the linter.
But it's like a 2 lines 10 or something, so it's a bit strange.
And color failed, but I seem to recall that at some point color. No, color is failing on the fixed point. So. Oh, and the error message we get in color is error cannot guess decreasing argument of fix. So I don't. What is the error message?
Probably it should not be a fix then. This thing should not be a fix.
No, but if the user tries to define a non-recursive fixed point, what error message does it get on the branch?
I mean the thing that you just said. Or if he specifies the argument, you mean, if he specifies the argument.
It's a bad error message, that's what I mean. Okay. It's cannot guess decreasing argument.
Yeah, so they are using a fixed point of.
Yeah, so we could enrich the messages by saying there are no possible recursive arguments for this fixed point or something like this.
Well, cannot guess means doesn't mean there are no.
Recursive fixed point, please use the definition or whatever.
Yeah, if we find out that it's fixed because of this. But when we're just guessing, there might be a natural number argument, which could be a fixed. I mean, when we're guessing the structural argument, it would be hard to change the warning. There's the error message.
But you have no recursive calls.
Exactly. Okay, I didn't know. Okay. Yeah, we should detect that.
In fact, it's funny because I think we have this check for mutual fixed points.
Yeah.
We should look at that.
No, for mutual
inductive. I seem to remember when you have a mutual fixed point with one body that is not actually recursive, we show where we.
Yeah.
There's a warning.
Show warning.
And for mutual inductives as well.
Yeah, so you could reuse that, I guess.
Yeah, something like this.
Yeah, but that's polishing. I would still advocate for merging that very short PR quickly because it's really your fault if you're right.
No, I disagree because it's look at the example of color.
Yep.
It's breaking existing code.
Yep.
So the error message that you get is critical. I mean, if you're porting the stuff to the new version of Coq and you cannot guess the critical error,
you have to make. No, I don't agree. You have to make your brain. You have to think like you're indeed writing cannot guess argument to fix. You look at the argument and you say there is a recursive argument. That's your problem. Like you can't probably just an entering the changes is enough. Because
imagine for a second that the term was built by a tactic. You see this message at QED?
No, you won't see that. This is.
You'll see something.
No, this error is actually triggered by the code in Venac.
It's a good point. You may see an even worse error message. We should check that too.
Wait. No, what happens if you write now? If you write induction, you get a distract actually, not like it's going.
No.
The only way
induction uses the
the elimination principle. So except if you write a fixed point by hand,
there is the fixed.
Or a tactic builds.
Let me check. Let me check what happens if I write.
You refine with fix.
Yeah, refine with fix with a stupid fix would probably get you into trouble. Yeah, but you're looking for it.
Should go through the same.
Yeah, fine. Okay, right. What the kernel is saying in that case is that is it going to raise an anomaly or something?
What?
If you do that, like. No, well, you'll probably get an error at QED that says that you're doing a recursion on non-inductive time, I guess. I'm not even sure. No, I think we decided to fix points. Well, let me check what is going on if you do that. I think that the error you get, the only error you get with cannot guess, is something way up, like it's in Vernac that happens, like the elaboration of fixed points and trying to guess the structure. Yeah, but it's that thing is not used by.
We're getting a bit off track from the
right.
discussion. Maybe we should
stop here. Completely off track. Yeah. The only thing I would need to know is I thought Mathieu's schedule until the release was loaded.
Yeah, it is loaded.
So, do you plan to also do that?
407? I can work on 407 this afternoon.
I'm just asking. I'm not putting pressure.
No. I think I can do that.
Yes.
Yeah, this one should be easy. And you mean also the primitive co-inductives and things like that, right? And the documentation.
Well, this I think. I mean, yes, it would be good to do it. I mean,
But I think the priority is clearly 407.
I wouldn't put the priority on it.
Yeah, I agree.
Because it needs more time.
Yeah.
The release is tomorrow. That's a good approximation.
Yeah. All right.
All right. So we're gonna have lunch and try to figure out what happened to the video.
Yeah.
For the discussion. All right. See you in 2 days.
See you.
2. Okay.
Yeah.
2.
Yes.
Maxime, what happens if Emilio doesn't show up? Do you discuss two requests or?
So
I'm sure I can make it for 2. I'm interested in the discussion about you, right?
Yeah.
Yeah. So you said you can make it or you can't?
I'm not sure. I'll try. But I'm not interested in the technical discussions.
Yeah. So if I hear back from Emilio, we will do the UI discussion at 2, I guess. Or is it better later for you, or
no? It's not. No, okay. It's the earlier the better.
Okay. So I'll try to get some news from Emilio. If I succeed, we'll do that discussion at 2. Okay. And if not, we will discuss the lockers, and I can send you a message to tell you when and if I have some news. But it could be that I have some news just 5 minutes before the. I mean, I don't really know. News from Emilio, I send you a message. So if you see no message from me, it means no news.
Okay, so
you have the real-time information.
Excellent. So if I see a message from you, I'll try to.
Okay. Very good. Yeah.
Would you say you see the army like a like Roger?
So lunch?
Si vous voyez une vidéo, prévenez-moi les gars.
Ouais.
Il vient à Paris normalement?
Nobody knows.
He's not going to Nice anyway.
Oui, il fait beau à Nice maintenant et il vient à Paris.
Il reste encore un peu de neige hein, sur les.
It's snowing. It's still snowing. Look at that.
Ah oui.
It's sharing of snow.
Do you have an option to disable it?
So what do we get for food, guys?
Sorry?
What do we get for food? We need to decide on something.
Yeah.
Should we go to the horrible pizza place?
We can also go to La Péniche, La Barge du Crous, if nobody has any.
And not too much inclined towards going to the Crous.
Yeah.
I know the place is nice, but still,
Okay.
like the Crous is like the Mensa, right? The Mensa is how they call that in Germany.
The Mensa.
Mensa.
Ah, Mensa. Un peu comme Metz. Ouais.
Je vais attendre un peu là.
Oh.
Ah, très bien.
Okay.
Ah, très bien.
All right, so what do we do?
Donc on mange son pas ou on attend tous?
Oh non, allez-y.
We could wait for
13h, ça va être un peu juste.
Ok.
Okay, fine.
Je vais juste chercher mes appels.
You're closing the door, right?
Oui.
You can leave it here.
Yeah.